Welcome, class. Just wanted to show you a little bit more about how to find the range and domain by inspecting the graph. In the previous examples that you probably looked over in your textbook, a lot of times you're just listing particular values. But when you have a graph, you have to remember that there's a wide range of X values or Y values that you have to address. So just remember, you're going to remember with what the domain is. Domain is all possible X values. So if we are trying to determine what the domain is by looking at the graph, I just go with looking at the X-axis to start off with. So just kind of inspect the values on the X-axis. And it sounds a little bit silly, but I kind of picture myself walking, maybe starting at the far left of the X-axis. I'll put hair on for now. Anyways, we can look at saying like whatever happens at the far left is probably happening at negative 100 or negative infinity. So if something's happening at this point, it would be kind of around like negative 4.5 right here. What I'm trying to look for is a corresponding Y value to that particular X value. So as I go, what's going on is I'm going to move along from the left to the right and just kind of look at the X values that I'm marking. Right now at the end, I have a negative 4. Notice if you look above or below or on your X equals negative 4, there's no picture. So we're trying to find the starting X value where we finally see a corresponding Y value above or below or maybe on the axis. So you notice I keep moving over a little bit and all of a sudden at negative 3, I finally see a picture above me. So what I can start looking at is if I have a starting value for my X, there's no holes in the graph, there's nothing tricky going on. So we assume that the starting value is negative 3 and we can use a bracket. And so what I want to kind of go over is if you keep traveling from the left to the right, kind of notice all the X values, even when you get to negative 2, all the corresponding Y values are on this line segment. So if you keep traveling a little bit before negative 1, you kind of see that you're on the X-axis, and that's okay because that means X equals 0 and Y equals 0. That's no problem. As you travel more to the right, you're going to notice that these corresponding X values give you Y values that are below the X-axis, or negative Y values. So if you keep traveling, you notice that you still have a picture for every single X value that you're marking. So at X equals 3, you have some sort of Y value down here. Keep traveling, we still see corresponding Y values below us. All of a sudden at X equals 4, we have that endpoint of that segment. So at X equals 4, looks like we're done. You could kind of test it out a little bit more. If you keep going further beyond the 4, notice that there's no picture above or no picture below. So you can say that that is the end of your domain. So finally, for this problem, the domain of this relation is negative 3 to positive 4. And then we use brackets because for the particular X values, see if I'll clean it up for you all just so that you can kind of look at it a little bit better. So again, I'll mark, here's my X equals negative 3 and X equals 4. What we're looking at is for that X equals negative 3, there is a straightforward Y value. In this case, it happens to be positive 1. And then for positive 4, X equals positive 4, the Y value is clearly negative 3. So that's why we use brackets. There's no holes or anything strange going on. So it does take a little practice, and I'll kind of even highlight so you can see the wide range of the X values. It's impossible to list all those numbers in between. Integers are nice, but you have to also account for the fractions and the decimals, which is why we're using the interval notation. So let me move on a little bit, talk about range. Same sort of idea. If we're looking at the range, we are looking at all possible y values. And I always kind of, when I used to learn this, I kind of remember like domain and range, I used to get them switched around, but kind of think alphabetical order. D comes before R in the alphabet, and as does X come before Y in the alphabet. So it kind of gave me a quick way to memorize. Oh yeah, domains helps me with the values of X, range describes what the values of Y are. So with the range, if we're looking at all the possible Y values, we then have to inspect what's happening on the Y axis. And just like we said earlier, what's ever happening on the far edges of the axis is probably happening at positive infinity or negative infinity. We happen to have a line segment, so we kind of see that it's a clear stopping point. But this time, if I'm looking at the y-axis, I'll imagine myself at the very bottom. So it looks like I'm kind of like at y equals -4.5 or so. And I notice in this case, I'm looking for corresponding x values this time. So at y equals like -4.5, if I'm looking to the right and the left of me, I don't see a corresponding picture. I don't even see a corresponding picture on the axis yet. So what we end up doing is we keep traveling. We say, okay, pick all those y values. So at y equals -4, do you see a picture to the right or the left of you? And we still don't. So keep going, keep walking along or climbing, I guess, if this is the case. And all of a sudden, at y equals -3, we finally see a corresponding picture. We see a corresponding x value would be probably at 4. So we now have that starting value for that range. And we can use a bracket because there's a clear x value, no holes or asymptotes or anything like that. And so keep traveling. Just traveling, kind of inspect what's happening. So we keep moving upwards, and notice for these particular y values at y equals -2, we have a corresponding x value to the right of us, or picture. That's what I always like to call it. Oops, got a little bit too zoomed in a little bit. That's nice too. And what happens is you could kind of look at, even before you get to -2, maybe like a -2.5, you see that it has a corresponding x value to the right. So keep traveling. There's always pictures to the right, or a graph to the right. All of a sudden, when you get a little bit above -1, you're on the y-axis. And that means that your y value looks like a little bit for -1 and your x value is 0. So that's still part of y value, a little bit higher. So keep traveling, go above this. Notice that at y equals 0, you have a picture to the left this time. And actually above that cutoff point right here, there's always a picture to the left. So you can keep traveling. Y equals 1, we start to see, we have our corresponding x value to the left at y equals 1. And then you notice if we keep going higher, there's no picture to the left or the right, or right or the left if you looked at how the order I drew it. So this kind of gives us a clear stopping point for our particular range. So let me clean it up a little bit just so that we see. I'm very visual and I have to kind of draw on things to help me see things. If this works for you, get some colors, work with it. But we can kind of see that the y values between -3 and +1 will give us our corresponding graph. And let's write that finally to be formal with the answer. So there's some interval notation for you. I kind of focus on interval notation a lot, mainly because we use it a lot more in our class. If the instructor wanted to use set notation, just kind of see and review what might work for that. So let's do a couple more, just to make sure we're clear. We rarely get line segments like we see in this last example. We start to get functions that we're going to start to be dealing with. And so this function, even though you don't really have to know what it is, there's certain behaviors that happen even though the graph doesn't always display it. So this is an absolute value function, and maybe you've seen it before. But those V-shaped functions, you want to kind of be on the lookout is just because your axis ends or your coordinate system ends, because we made a grid here, does not mean that your function necessarily ends. So kind of remember the behavior. If a graph goes all the way to the edge, it probably continues in the same direction. We could almost bet on it. So if I'm going to look at finding the domain, I gotta remember to label it if there's no label for myself. Remember, we're going to look at this x-axis. And ourselves along the x-axis, and we'll just go x value. So what happens at the very edge, and this is usually what's happening at the very edge, again, is happening at -100, as is happening somewhere along the negative infinity. So if you're looking at the x equals -2.5, you kind of can look up and you notice that you don't quite see it based on the picture. But remember, the graph behaves in such a way that it goes on and on forever, indefinitely. So technically, even though you don't see a picture, it is there. It does have a corresponding y value. So that would mean if you were hanging out on x equals the -100, there should be a corresponding y value way above you off the screen, as there would be if you were standing on the negative infinity. So we kind of can determine the starting point for our domain. I don't know if we can really call it a starting point, but I will. That if it's happening at the far edges of the axis, it's probably happening at negative infinity. So my quote starting point would be negative infinity. Remember, we don't really actually reach infinities, so that's why we're using parentheses out with the interval notation. And then let's continue. So as we're walking, I said x equals -1. We do still see a picture above us. That's still good. Keep walking along. At x equals 0, we still see a picture. We're in good shape. Still see picture. And all of a sudden we get to, maybe it's about like x equals 1/2. We're still in good shape because that just means the y value is 0. So once you get beyond this part where the x-intercept, you kind of notice values beyond this will be now below, or I could say the corresponding y values are below. So you notice at x equals 2, you actually hit that little apex? I don't know. I'm mathy, so I don't remember the language, but it's kind of the point of your V. It's not quite a vertex, but I digress. Anyways, what's going on is we keep walking along the x-axis. So now we're at x equals 3, and we still notice like, oh yeah, we still have corresponding y values all the way below us for all these x values. We hit another x-intercept, so that means y 0, we're good to go. We go beyond this, x equals 4, and we kind of see, oh yeah, cool, still got seeing corresponding y values for every single x value that we're stepping on. And then we get to the far edge of our x-axis. In this case, according to the way it's labeled, it might be a little small, but maybe that's at x equals 6 or so. Because of the behavior of the absolute value function, we still have a picture somewhere above us. And if we do keep on traveling to higher values, there will always still be a picture above. So if it's happening at the far edges, the idea is it's happening at the infinity part. So the domain for this absolute value function is actually going to be negative infinity to positive infinity. And in interval notation, we're using those parentheses. Some people also note whenever you get this sort of notation, people say all real numbers. It's a nice way to say it in English. But I'll focus on interval notation. So there's the domain. So notice we up a bit. And maybe this is a little bit nicer way to approach this, is that every single x value will give you a corresponding y value on your x-axis. That's where we get the domain from. And we will do about the same thing for the range. Make sure you label them if there's no place to write a blank, so that people know that you clearly know the difference between the range and the domain. So with range, we start with looking at the y-axis. Sometimes they're not centered, so I make sure you're going through this. What goes on? Start yourself. And this, I guess, would be climbing this time around. So it looks to be like -4.5. And if you're looking to the left or to the right of yourself, there is no picture. So you kind of keep going. And all of a sudden, notice even before, we still don't see picture. But y equals -3, it's giving you a starting point of -3. And because it's a clear value, nice clear x value, there's no holes or anything like that, we are going to use brackets to indicate that the -3 is included in the range. And keep traveling. Notice that for all these y values, we are still seeing corresponding picture to the right. You kind of can skip a little bit. You don't have to keep drawing a bunch of them. So at y equals 0, we do have a corresponding x value to the right. Keep going. Notice now we're hitting the y-axis. That means x is 0. That's still a good number. Keep going, and this time when you're beyond the y-intercept, you'll notice that your corresponding graph is to the left of you now, and that's kind of indicating that you still have a corresponding x value for every single one of your y values. So again, with understanding that the absolute value function goes on forever and ever, it is safe to assume that if you were at the tallest part of your y-axis, in our case it's a little bit above the number 3, there is a function forever and ever. So it is going to be, if it's happening at the far edges of the axis, it's probably happening at infinity. So our range, y values will span from -3 to positive infinity. And so if I can clean that up again, just so that we can see what values give us the picture. Again, starting from -3, well, I'll be a little bit more precise for you. So starting at -3 all the way up. So that's kind of giving us a clear picture, like, okay, that's the starting point of our y value, and there is really no ending point for the y value due to the behavior of the actual function we're looking at. Ready for another one? I take that as a yes. So we're going to look at one of these sleeping parabolas. And what we're kind of trying to decide, again, with domain and range, might be useful to just label what we're looking for. Okay, so if I'm looking at the domain, one more time, I'm looking at the x-axis. And I could kind of see where the function stops, but I'll kind of just kind of know where my focus is. Start at the far edge, or the least possible value of x. In this case, it looks to be like -2.5. And what you're trying to do is look for a picture above, below, or if you're stepping on it or so. So again, with the behavior of these sleeping parabolas, they have the behavior, if they hit the far edge of the axis, if it was meant for you to stop, you would see clear, clear line segments or points. But behaviors of these functions indicate that we're going on forever and ever in about the same direction. A little crooked on the top. Here we go. So for x equals -2.5, you're going to notice that you actually end up having two y values. And that's fine. It just means that your picture exists. So at x equals -2, again, we still see a picture above or below. Even decimals in the middle, from -1 and -2, we still see a picture above, below. X equals -1, we still see a picture above or below, even the decimals. And you kind of notice that it's not just the integers we're dealing with, it's all the numbers in between these integers. So you can kind of see that every time you're traveling, it's going to take me a while, so I'm going to skip a little bit. Every x value that you're going with is actually, you are seeing a picture above and below. So it looks like if it's happening at -2.5 at the edge of our axis, it's probably happening at -infinity. And I'm kind of looking to see if there is a stopping point. So I kind of see like, oh yeah, I keep traveling along these x values and I can clearly see there is a picture above and below me at all times. Doesn't have to be both, but we're there. Picture above, below, still a picture above, below. And we keep traveling all the way until we hit x equals 9. And we are actually on the x-axis, so that means the y value is 0. So that means the picture still exists. But the moment you go beyond the 9, there's no more picture above or below you. So even when you look at the far edge of your axis, like -10.4 or something like that, there is no picture above or below you, so you can assume the same thing is happening at positive infinity. So where is that stopping point? X equals +9. And again, because you're actually, there's no holes or anything strange going on, we're using brackets to indicate this. So one more time, I'll clean it up just for you, just to see. A little visual. Our domain is starting from -infinity and it's stopping at 9. And that's giving us our sleeping parabola picture. Okay, now we're going to look at range one more time. And I'll label it so that we know what we're going with. Remember, with the range, we are looking at what axis? The y-axis. So I'm going to kind of remind myself to look there. And here again, starting at the least possible value at the y-axis, we are looking at y equals like -4.2. Well, we're kind of seeing, do we have a picture to the left or to the right of us? Nothing to the right. And to the left, it doesn't appear like it is. But remember, these behaviors of these sleeping parabolas, they go on in the same direction, slightly widening out as we get further. I've done a little bit of exaggeration here. So technically with the range, there is a picture to the left of you. We just can't see it on our grid, our coordinate system that we have. We call this a window. So with the range, if you're kind of looking at the starting point, well, if it's happening at the very far edges, if it happens at this -4, if you were down here at -100 or so, there would still be a picture somewhere to the left, as would there be from infinity. So the range is actually starting at -infinity. And then we'd play the same game, traveling, noticing that every time we're looking at a y value, right now, the picture looks to be to the left of us. We do hit the y-intercept, looks like it's at -3. That's part of the range. It's not a starting or stopping point. So we keep going beyond, and once we go beyond this y-intercept, we start to see that, oh yeah, the picture ends up being to the left of us this time around. So we kind of can say like, oh yeah, we still have a lot of picture going on. And we do have another y-intercept, and that's still part of the range. It's not a starting or stopping point. It's just indicating that you have corresponding x values for those particular two y values. Happens to be 0. But everyone in between the y-intercepts, it looks like those corresponding x values to end up being to the right of you. Once you go beyond, your corresponding x values will be to the left of you. So we could kind of see, okay, here's the far edge of the axis again. Do you have a picture to the left or to the right of you? For sure not to the right, but to the left, even though you can't quite see it, we do see that there is going to be some picture eventually. So this tells us that our entire y-axis is filled. So that gives us a range of -infinity to +infinity, otherwise known as all real numbers. So this takes a lot of practice. Don't be afraid to take in a few more examples. I think there should be something to look at, a lot more pictures than what's in the text. I should have some worksheets for you guys that correspond to that. So hope this helps. I'll see you next time.